Hi, and welcome back. Today we're going to cover Module 9, where we'll look at nomenclature systems for metals and also the impact of processing on metals. The learning outcomes for today's module are to understand the widely utilized numbering designations for steel and aluminum, and also to understand the impact of various material processes and treatments on the material properties of metals. So let's start out with steel. Last module we talked about how strong steel is. The numbering sequence for steel will typically be four numbers. The first number pair will indicate the composition code of steel. So for example, 10 in this AISI 1040 steel, 10 indicates that the steel is a plain carbon steel. There are no other alloying elements in there. For the AISI 4340 steel, the 43 indicates that it's a nickel-chrome molybdenum or nickel-chrome moly steel. There's a number of different pairs that designate specific compositions for steels. You can see them here. So we have plain carbon, 23 means nickel, 41 means a chrome moly steel, 46 means a nickel moly steel, 50 means a chromium type of steel. The second number pair in the steel indicates the carbon content. So this 40 in 1040 steel indicates that it is 0.4% carbon. And this 40 in 4340 steel, again, indicates that it's 0.4% carbon. And if I were to look at 1010 steel, the second 10 would indicate that it's 0.1% carbon. All right, let's take a look at the aluminum designations. So for aluminum numbering, there's a prefix, the letter A, and that indicates that it's an aluminum metal. The first number indicates the processing it's gone through. 0 is cast iron and 9 is wrought. The second number is the main alloying group. So typically you might see something like a 6,000 or 6 would mean that it's the type of alloy it is. So for a 2000 group, it's a copper alloy, and for a 6000 series, it would be a magnesium, silicon, and silicon alloys. The third number indicates the modification or impurity limits, and the last two numbers specify any other alloys used. So if we look here at this example, UNS A96061. So the A indicates that it's aluminum, and the 9 indicates that it's a wrought aluminum, and the 6D or the 6000 indicates that it's a magnesium and silicon alloying elements. This aluminum is commonly referred to as 6061 aluminum. So a lot of times you'll hear designers saying things like, I'm going to use 2024, I'm going to use 7075, I'm going to use 6061 aluminum. So it's really common when people talk that they'll leave out these first numbers in design meetings. All right, so heat treating and cold working. These are two types of processes that metals experience. Cold working means that you're forming the metal at a low temperature. And when they say low temperature, they typically mean room temperature. The nice thing about cold working is that it's very accurate. It can get you a fairly large increase in both yield and ultimate strengths, as well as hardness. The downside is that it dramatically decreases your ductility. So heat treating, these are time and temperature controlled processes. Quenching is when you heat the metal up to a high temperature and then you control the cooling rate. Typically quenching is done quite rapidly. It increases the strength, the hardness, but it decreases the ductility and it can leave residual stresses in the material. Tempering is when you heat the material up to below the critical temperature for the material and hold it there for a certain amount of time. What tempering does is it relieves the residual stresses, it restores the ductility, but it reduces the strength. So in both cold working and heat treating, you're essentially in this balance between where you're trading off between increasing your strength and decreasing your ductility, or restoring your ductility and then decreasing your strength. All right, so let's take a look at different notations. You'll see numbers like this very commonly in military standards or ASTM standards or at the back of your textbooks, and it's important to understand what all the different notation means. So let's start at the top with steel. For 1010 steel, you can see that it's giving you its AISI number, 1010, so again, you know it's plain carbon steel, and it has a carbon content of 0.1. Here the processing says that HR, that means hot rolled steel, and CD, that means cold drawn. And you can see what I just talked about happening here. So the hot rolled steel is not as strong as the cold drawn steel. It has a significantly lower yield strength. But the hot rolled steel has better ductility. It has a more elongation than the cold drawn steel. So then if we look at 1045 steel, so again, we've increased the carbon content, and now the carbon content is at 0.45%, which causes an increase in strength. So we start to see that increase in yield strength where this steel is stronger than the 1010 steel. And then if we go to a 1095 steel that's been quenched and tempered, so that's what Q&T stands for. It stands for quenched and tempered, and then it gives you the temperature it's tempered at. You can see much higher strengths, and again you see the steel that has the higher tempering temperature at 650 degrees C is at a lower strength. All right, so then let's go on to the aluminum. Oh, I'm sorry, we have one more steel. 4340, so this is a very strong steel. It's commonly used in the aircraft industry. So 43 is again referring to the type of alloying elements that are in there. The 40 is the 0.4% carbon, quenched and tempered, and we can see that here you're hitting the gigapascal range of strength. So this is a very strong steel. The steel that has been tempered longer has better ductility, but is less strong. Tempered at a higher temperature. Okay, so then we can move on to the aluminums. So for 2024 aluminum, that's an aluminum with a copper alloying in it. The temper that they're referring to is T6. And that's just telling you the type of tempering it went through, whether there was a solution and how long it was tempered for, whether it was cold worked afterwards. You can look up the designations. They're all on Wikipedia and see what's happening there. So then we can also see 6061, which is one of the most common aluminums utilized in the aerospace industry. And again, it gives you the temper designation of T6. So this is how you read standard material properties for strengths and what all the numbers and various abbreviations mean. And we'll be utilizing these throughout the class when you're trying to calculate stresses and then compare them to strengths. So it's important to understand these. And it's always important to use the correct material processing. So what you never want to do is have your design be a 1010 cold rolled steel, but be calculating the factor of safety off of the hot rolled steel. So you need to always make sure that your processing and your alloying elements, everything is taken into account when you're looking up the strength and that it matches your specific design. All right, so these values came from Mill Handbook 5J, which is a great source. And that's all we have for this lecture. I'll see you next lecture.